dominated strategies, we say that an action xj in xi is epsilon dominated by action xk in xi if for any x minus I in x capital X minus I, we have Si of xj x minus I greater than or equals to epsilon plus Si of xk x minus I. Similarly, action xj in capital Xi is epsilon dominated by a mixed action y in delta of xi if for any x minus I in a capital X minus I we have Si of xj x minus I is greater than or equals to epsilon plus the expectations of Si of xd x minus I if we assume that xd is very close to y. Intuitively, a good learning algorithm ought to be able to learn not to play actions that are epsilon dominated by others, and in this section we show that indeed if a player I plays a procedure with a sublinear swap regret, then it will very rarely play dominated actions. More precisely, let action xj be epsilon dominated by action xk in xi using our notation. This implies that for any x minus I, we have that regret I of x, switch I of dot xj xk is greater than or equals to epsilon. So the regret I is greater than or equals to epsilon. Let d epsilon be the set of epsilon dominated actions of a player I, and let W be the weight that player I puts on actions in d epsilon, averaged over time, i.e. W equals to 1 over t times the summation, doubling summations, with the outer summation summing for all those t starting from 1 to capital T, and the inner summation summing for all those j in d epsilon. The term inside of doubling summation is pi j to the t. Player I's swap regret is at least epsilon times w times t, since we could replace each action in d epsilon with the action that dominates it. So if the player's swap regret is r, then epsilon times w times t is less than or equals to r. Therefore, the time average weight that player I puts on the set of epsilon dominated actions is at most r over epsilon times t, which tends to 0 if r is sublinear in t. That is, theorem 4.13. Consider a game G and a player I that uses a procedure of a swap regret R for t time steps. Then the average weight that the player I puts on the set of epsilon dominated actions is at most R over epsilon times t. We remark that in general the property of having low external regret is not sufficient by itself to give such a guarantee. So the algorithms RWM and PW do indeed have such a guarantee. See exercise 4.8.